Let's look at integrating improper algebraic fractions. So the examples say, part A, integrate x squared plus 3x plus 3 divided by x plus 1 with respect to x. Part B says integrate x cubed over x squared minus 4 with respect to x. Part C says integrate 6x to the power of 4 plus 12x squared minus 18 all over x squared plus 2x plus 1 with respect to x. So when integrating improper algebraic fractions, we should always start by using long division. Here we've set up our long division, so we'll start with x and we'll see what do we times x with to get x squared, which in this case is x. And so x times x gives us x squared, 1 times x gives us positive x, and now if we subtract the two quadratics here, we end up with x squared minus x squared, which is 0, 3x minus x, which is 2x, and then 3 minus nothing, which is plus 3. And now we check what do we times x with to get 2x, which in this case is plus 2. So 2 times x gives us 2x, and 2 times 1 gives us 2. And now if we subtract these two, we end up with 2x take away 2x, which is 0, and 3 minus 2, which is 1. Since we're dividing by a linear expression and we're left with a constant, this is now our remainder. And so the integral becomes the integral of x plus 2 and then our remainder divided by x plus 1, since we haven't divided the remainder by this just yet. And so if we integrate this, we now get the following. So adding 1 to the power of x, we get x squared, and then dividing by this power, we end up with a half. And then the 2 becomes 2x, and now 1 over x plus 1 is of the format f dash of x over f of x, since we have a constant over a linear term. And so this ends up becoming plus ln of x plus 1, and the modulus of all of that. And now since we have indefinite integration, we also have plus c. The second integral, again, we have an improper algebraic fraction, and so we're going to start by using long division. For the first step, we're going to see what we times x squared with to get x cubed. In this case, that's x. So x times x squared gives us x cubed, and x times minus 4 gives us minus 4x. And now we're going to take these two away. So now we end up with x cubed minus x cubed, which is 0, and then 0x minus minus 4x, which becomes 0x plus 4x, which gives us 4x. And since we're dividing by a quadratic and we have a linear term here, this is now our remainder. So this integral can be written as the integral of x plus our remainder, which is 4x, over what we're dividing by, which is x squared minus 4, and we're integrating with respect to x. For the second term here, we can use partial fractions to split this up, and so we have 4x over x squared minus 4, which can be written as 4x over, and now we have the difference of two squares in the denominator, so if we factorize this, we end up with x plus 2 and x minus 2. Using partial fractions, we have 4x over x plus 2 brackets x minus 2, which is equal to a over x plus 2 plus b over x minus 2. If we times both sides by the denominator, on the left hand side, if we times by x plus 2 and x minus 2, we'll just be left with 4x. And now the first term, if we times by x plus 2, the denominator will cancel, and if we times by x minus 2, we'll be left with a brackets x minus 2. And then for the last term here, if we times by x minus 2, that will cancel with the denominator, and if we times by x plus 2 as well, we end up with plus b brackets x plus 2. Now if we let x equal to 2, then we end up with 4 times 2, which is equal to 8, and then on the right hand side, 2 minus 2, which is 0, and 0 times a is 0, and then we have plus b, and then in brackets now 2 plus 2, which gives us 4. So 4 times b is what we have on the right hand side, and so if we divide both sides by 4, we end up with b equaling to 2. Now if we let x equal to minus 2, then we see we end up with the following: 4 times minus 2, which is minus 8, and then we have in the first bracket minus 2, which is minus 4, times a, which is minus 4a, and in the second bracket here, minus 2 plus 2 will give us 0, and 0 times b is just 0. So now dividing both sides by minus 4, we end up with 2 equals to a. This integral now becomes the integral of x plus, and now this second term can be written in partial fraction form, where we worked out that a equals to 2, so we have 2 over x plus 2, and then we have plus, where b is equal to 2 as well, so 2 over x minus 2. And we're integrating with respect to x. So if we work this out, we add 1 to the power of x, which becomes x squared, and then we divide by this new power, which gives us a half, and then the second term integrates to 2 times ln of the modulus of x plus 2, because this is of the form f dash of x over f of x with a constant 2. And then the last term integrates to 2 times ln of the modulus of x minus 2. Because again, this is of the form f dash of x over f of x with a constant of 2. Since we have indefinite integration, we're going to add c. For the final example, again, we have an improper algebraic fraction, so we're going to start by using long division. And so we have the numerator, which is being divided, and we've also added on 0x cubed and 0x because there is no cubed or linear term. And we're dividing by x squared plus 2x plus 1, which is the denominator. We start by seeing what we times x squared with to give us 6x to the power of 4, which in this case is 6x squared. And so 6x squared times x squared gives us 6x to the power of 4. 6x squared times 2x gives us 12x cubed. And 6x squared times 1 gives us 6x squared. Now we're going to take these away. So 6x to the power of 4 minus 6x to the power of 4 is 0. 0x cubed minus 12x cubed gives us minus 12x cubed. And then we have 12x squared minus 6x squared gives us 6x squared. And then we have 0x take away nothing, which is 0x. And we have minus 18 take away nothing, which is minus 18. Now we check what we times x squared with to give us minus 12x cubed, which in this case is minus 12x. So minus 12x times x squared gives us minus 12x cubed. Minus 12x times 2x gives us minus 24x. And minus 12x times 1 gives us minus 12x. And so if we take these away, we end up with the following. Now we have minus 12x cubed minus minus 12x cubed, which becomes minus 12x cubed plus 12x cubed, which is 0. And then 6x squared minus minus 24x squared, which becomes 6x squared plus 24x squared, which is equal to 30x squared. And then we have 0x minus minus 12x, which is 0x plus 12x, which becomes 12x. And then we have minus 18 take away nothing, which is minus 18. Now we check what we times x squared with to give us 30x squared, which in this case is plus 30. So 30 times x squared gives us 30x squared. 30 times 2x gives us 60x. And 30 times 1 gives us 30. Now we're going to take these away. So 30x squared minus 30x squared is 0. 12x minus 60x becomes minus 48x. Minus 18 minus 30 becomes minus 48. And since we're dividing by a quadratic and we end up with a linear term, this is our remainder. And so this integral is now equal to integral of 6x squared minus 12x plus 30. And then we have our remainder, which is minus 48x minus 48 over what we're dividing by, which is x squared plus 2x plus 1, and we're adding this on. Now if we look at the final term, which is this fraction, if we factorize this, we can factorize minus 48 out from the numerator, which leaves us with minus 48 times in brackets x plus 1. And now the denominator is a quadratic, which if we factorize, we're looking for two numbers that times to make 1 and add to make 2, which in this case is 1 and 1. So the denominator factorizes to x plus 1 brackets x plus 1. And so one of these brackets cancels nicely, so x plus 1 and x plus 1 goes. And so we're now left with minus 48 over x plus 1. We can use this simplified version in our integral. And so we now have that this integral is equal to the integral of 6x squared minus 12x plus 30. And now we have minus 48 over x plus 1. We're integrating with respect to x. And so if we integrate this, we end up with the following. Adding 1 to the power, we end up with x cubed. And now dividing by the new power, 6 divided by 3 becomes 2. And then for the second term, we're going to add 1 to the power here. So this becomes x squared. And then dividing by this power, minus 12 divided by 2 becomes minus 6. And then for the 30, we're just going to convert this into 30x. And this final fraction integrates to minus 48 times ln of the modulus of x plus 1, since this is of the form f dash of x over f of x with a constant. And since we have indefinite integration, we have plus c on the end. This is how you integrate improper algebraic fractions.